Welcome to our data science bootcamp. Right now, we're in a mini course, the Xpert Logistics Solutions Project is what we're currently on. All right, guys, and I'm just giving a sneak peek of some lesson planning that I'm doing for my students. I figured this would be a really great opportunity to introduce some data science and a real world project that my students might get when they're actually out working in the field. All right. So let's say that after our program, you hire on, which we know is going to happen, and you end up working for a logistics company. All right. So that's going to be the scenario in this entire series. All right. You're going to wear different hats on the teams that you guys are assigned to, if you would like, or you can pick a particular position that you can stick to. But let's just go through the scenario. Okay. So let's say that your client owns a logistics company, all right, and they own a simplified warehouse, right? This is their entire service, their entire operations, all right. So they have some packages that are coming down the belt, and they need to be loaded to the correct vessel, and then within the vessel, they need to be loaded in the proper position, all right. And in this exercise, our job is to optimize the sort time, aka either increase the number of packages that are sorted and loaded per minute, right? That's the main way to think about it. Or you might have it rephrased as reduce the number or reduce the time required to load the same packages. All right. In our example, when we present this to our client, per our marketers, they're going to present this as we're going to 4x productivity, right? So we're going to quadruple the number of packages, right, that can be correctly loaded to each vessel using data science. All right. So that's our job. That's what we've been hired to do. So that's how they're gonna one up their competitors. They're gonna optimize their sort and load time using data science, and then they're going to, in some way, use that to one up their competitors. All right. So let's just go through this example and what some of the challenges are. So as of right now, their sort is in this case done manually. So essentially, you have two sorters up here. You have a sorter on your left side and a sorter on your right side. And what's happening is these packages have been pre-sorted to only belong to just the vessels over here. All right. So let's say there's other areas in warehouse, other vessels in other places, but the packages that end up in this area will only go to these vessels. All right. So let's say by the time they get to this destination, we're just dealing with packages that belong to this vessel. All right, so they're coming down this belt. So they hit this sort area one, and they're gonna get split east and west. So let's go ahead and put us a little text there just to make that abundantly clear. I'll just grab what's like a one here. So the technically speaking, the first sort happens before it even reaches here. So technically speaking, we have a pre-sort, and let's say that that's for only our vessels. So only our vessels. That's what I'm going to say to keep this simple. And now the next sort is going to be whether it's going to be on we're going to call this our east side, and we're going to call this on our west side. All right. So let's say that once the packages enter here, this is the first place where we have second place, but in our example, it's going to be the first place where we have human intervention. And let's say this is where they either get a west or they're on our east. All right. So now the packages have been further sorted. All right. So the packages on our east are only possibly loaded to these vessels. And the packages on our west are only possibly loaded to these vessels. All right, so the next kind of like optimization that we've kind of thought of so far is what if we put another like kind of sort almost like right here, either right here or right here. We're not sure. We can test out different endpoints, or sorry, different points where the next sort happens. But what if we had another sort that then goes north and south? And by north and south, let's say that in some place, right, that only packages that belong to vessels that's on this side, right, can go past this point, or they go on this side, sorry, that only packages that belong to a vessel that's over past this line can make it here. So let's say we have another sort here, but this time this sort is going to be our north and our south. All right, our north and our south, or north and south. So let's go ahead and make this our north. All right. So if you have a certain package, you'll be our northeast or our northwest, and then we'll have our southeast and our southwest. All right, and let's put our south over here. All right, guys. So actually, yeah, so we have our north, we have our south, we have our east, and we have our west. Let's say that those are places where we have some sort of extra sorting, some extra splitting here. All right. Let's just say for now that we added human intervention. So let's say right after, I'm going to get rid of these actors because actually let's put these here. They're manually loading these units. That's what they're doing. So let's put you here. Actually, let's leave you here because you're going to be our next splitter. And let's say that you're over at your asset. Okay, so let's say that we put another splitter here. All right, so the splitter that's on this side, right? So this splitter is only going to be dealing with West packages. And what this splitter is going to do is if a package is of over a certain unit, right? Then the package will get split and it'll go back this way to one of these vessels. And if not, it'll get split and it'll go this way and it'll go back to these vessels. And the same thing is going to happen on our east side, right? So our next splitter package is going to come after it's come down this way, right? So our first splitters have made our east and west. And now our next set of splitters are going to do our north and south. And from here, what's going to happen is our package is either going to come this way and it's going to go back, boop, and it's going to know it's a part of one of these vessels, or our package is going to go this way and know that it's a part of one of these vessels. All right, so let's say that's just one way that we propose to optimize the sort time. All right, let's say that's proposition one. Let's say like we do this experiment. So let's say our baseline is the way that they currently split, right? So the current split is that we have some sort of pre-sort that happens first, and now it's down to just our vessels, and then we just do an east and west split. And from there, pretty much our loaders are reading the package labels to see. So they're touching every package. So now let's put our actors back in here in scenario one. So in scenario one, let's take out our splitters. Let's take out our north and south splitters for a second. Let's remove them for a second. Let's say we didn't have our north and south splitters. All right, so if we didn't have our north and south splitters, what we have is there'd be an actor for each vessel right here on the line, right? They're here on the line, and they're scanning, they're looking at every package, right? They're looking at each package to see if this package belongs to my vessel. Now, each loader could have up to, either one to let's say in our scenario that they can have between 1 to 3 vessels assigned to them. All right. And so they're looking at every package. Well, let me say that. Let's say that they're only looking at half the packages. Now, I know in this scenario, and this is something we're actually going to test out statistically, the percentage of packages that are north, south, east, west, and using a weighted average in that way to optimize. But let's just hold that. Let's take that out of the equation for a second. So let's just assume for a second that exactly 50% of our packages end up in the East and 50% of our packages end up in the West. Or let me just rephrase this. Let's just say there is it's not easily enough determinable if a package will be theirs or not. So they have to scan every package on that they come across, right? So they're located on the east side, for example. So they have to look at every east side package, which is exactly 50% of the population of packages. So that's 50% of the population of packages that each one of our workers has to scan, all right, to see if that package belongs to their vessel. Well, firstly, we reduce, right, how many packages our workers have to even look at in the first place, because we've reduced right, so because we have this second split here, right? So now because we've split right here our north and south, well, now my loader isn't looking at packages that belong on the south side. My loader is only looking at packages that belong to the north side, right? So I've reduced the population and increase the possibility that the package that they're looking at is their package. So that's one way. Like I said, that would be a comparison. What was another one? So we're basically like in this exercise, as part of this program, we're going to be testing out different experiments to see if we can optimize the load time. Now, another thing, and I'm going to wrap up after this because I have another meeting to get ready for, is we want to see. Now, this part is going to be really fun for you guys. So make sure you guys tune in for this part. Now, one of the complaints, let's just say hypothetically speaking, right, after our data scientists and our BI developer go on site, let's say after they speak to some of the employees, they say like, hey, one of the things that kind of takes me a while to load okay, let's say that they say there's two main things that takes them a while to load their vessel that affect sort time. Let's say that it's the fact that they have to like read the labels, right? So these packages are coming down the belt, first of all, and they're not always flipped the same way, and not all of the labels are on the same space. And you don't have packages that are all this same color. These packages are sometimes they're white and the label blends in. Sometimes the labels are on the back, sometimes the labels are on the front. So just purely locating the label and reading the label to determine whether that package belongs in your vessel. That right there, that takes time. All right. The next thing is where do I, and this is the biggest one. So let's say when we went out and we shadowed this warehouse, we noticed there was a lot of packages stacked up. Let me just grab one of these. Let's say we noticed there was a lot of packages just stacked up in their area. And it's because they don't know exactly where to load their package within this vessel. So let's say that the real challenge is, okay, I've got this package, right? I've got this package that could be small, medium, large, XL, and then we have other. I have this package. Let's grab us a package, right? Now, the question is, where in my vessel do I load this package? All right. Now, I have some information on my label that says that, this package belongs in Q1, right? Or Q4, or Q2, or Q3. Now I'm using quadrants. Now, typically inside a vessel, you might see like 1500 or 6500 or a different numeric system. I'm just using quadrants right now to represent the different sections that a vessel could have. So let's say that this package, right, if we look at our labels, it has some information about what vessel it should be on. And this O stands for odd and this E stands for even. And then let's say this Q stands for quadrant. So like maybe let's say that this part is going to tell me whether this is a 1200 or if this is a 2400. And then finally, P stands for position. So let's say within my Q2, there's a position 1, 2, and 3, right? And let's say that the real challenge is this package could go in quadrant 1, right? So let's say that this is, in fact, vessel A1, and it is in quadrant 2, but this could go in quadrant 2, place number 1, 2, or 3. All right. And the more possible slots that and let's say, for example, now I would have to look more into this, and let's say there are packages who have the exact same location sticker, because up to, so let's say that instead of them calling this position 1, 2, and 3, they said this is position 1, they called this TOQ1P, and they gave these 3 packages the exact same code, because those 3 fit into that positioning. Instead of saying like, okay, you guys are all going to the same quadrant, but you're going to be 1, you're going to be slot place 1, you're going to be slot place 2, and you're going to be slot place 3. This is faux. This is definitely something that the data scientist and the BI developer would need to chat more with the team about. But let's say that one of the biggest factors are those 2 things: the label visibility, and then knowing exactly where to load the packages once you get them to your vessel. And let's say that we notice that, like, okay, the teams, they're able to pretty much, get the packages off the belt, but there's just like, if I look down the line, there's just packages and packages and packages everywhere. Our veterans pretty much might know, okay, this is how to, properly load, a vessel, and you put this here and all that. But, maybe there's some sort of guideline that we can offer, as far as like, or maybe there's some type of optimization in the labeling system that can better determine off gate, just by looking at the label, exactly where in this vessel should I put this package, and how should I lay this package, right? Should this package go this way, or should this package go this way, or should this package go this way? And they don't have to guess about that, right? When they scan the package, it'll tell them and even show them, and it'll light up. Let's say that when they scan this package, right, there'll be like a little diagram that shows this vessel, right? Let's say that this, you see how we have positions? Let's say that when they scan this unit, that this position in this quadrant lights up, and then it even shows the angle and where this package should be placed. And let's say that this system is also smart enough to, now here's where I'll get into the complexities later, right? So let's just say it says I already thought through how to correct that. Let's say that we scan this package, right? And it says, okay, this is vessel VA1, quadrant number 2, position number 1. And we place that there. And now our system actually knows that this position is taken, and there's a little heat, or a little like it's color coded, so that if I pull up this vessel, it shows that this package is in this position. All right. Now, let's say that we haven't had all of our trailers come in and give us all our packages. And now we have a new package that somehow it makes more sense for that new package to have this position. Or our system should be smart enough to bump this package out and to tell to give this new package a new place. And if there's any other updates that need to be made, that it'll step our scanner through it. So let's say that the scanner now scans this new package and it'll tell them that like, some type of update is made to go into the unit. And then it'll have like step one, move package one to this position. Step two, move this package to this position. And even if they need to take a package out of the vessel and to place it outside in the hold, they'll get that instruction and then get this new package and then place it in this position. All right. And that's going to happen in an instant because we're talking about them scanning a package and a computer producing this information. So that's one way we thought about optimization. Now, another way we thought about optimization is pure visibility of the package. Now, let's go through this. Now, where to put this? Okay, let's say that what we're trying to do is train an ML model that would be able to properly classify a package just based on the outer appearance. So let's say that we could not see the labels at all, right? And we needed to make an educated guess about which vessel these packages belong to. All right, I'm gonna take off now. I put initially the position too, but it doesn't need to guess the position. The only thing that this needs to guess is which vessel this package belongs to. So let's say that that's our whole thing, and that our labels can be however many units. Our labels can be however many units of trucks or vessels that we have. So let's say that our labels are, I'm saying T here, but this should really be V. Let's say that our possible labels can be V1 through V10. All right. And what we're doing is looking at the outer packages, not the labels, and seeing if based on outer features that is way easier to see, can we guess which vessel this belongs to? Now I'm gonna give you guys a hint. Now, one of the ways that I thought about training this is based off of the most recent similar package. Now, let's say that the data team, as they were on the job, they noticed a few things that especially packages that come from certain vendors, they tend to go to the same vessels. So if vendors are all like if similar vendors are going to similar trucks and these vendors are packaged in certain packages, well, those packages are way easier to basically classify, right? If I see a bright yellow, if I see a dark blue Lululemon package coming down my belt, and I know that Lululemon is going to be on our east, our northeast, then I already know that this is the section that Lululemon is going to go in without me even needing to take the time to read the label. All right. By the time I read the label, I'm just trying to figure out where to position this inside my vessel. So that's one way. So yeah, so that was one of the challenges. Can we train an ML model that just based off of the packaging and size? That's another thing. So size. And I know you guys are saying like, there's no way. Now, here's something we noticed. Packages that were of a certain size tended to go to a certain vessel. It got to a point where like we could just look at this box or this package and be like, oh, this is a da-da-da-da, and say like what unit number that belongs to. And it's because, again, if we take a step back and think about the real business use case and ask ourselves, like, what is actually being shipped and by whom, they probably use what? Similar packaging, right? like, do you guys get where I'm going with this? Like, these vendors are probably using similar packages. And if these vendors are all shipping out to certain vessels, then that's an easier way for us to be able to either quickly identify where this package goes without having to scan. And so that's something that we test out. And essentially, what we're testing out is, can we optimize our sort time? And more important, and moreover, can we have different variables? Essentially, where's our little formula that I came up with? Okay, so F of location. So predict the location, and then F of, I guess this would be like F of vessel. F of vessel. This is actually just going to be the vessel label. So this is just going to be like V1 through V10. These would be the possible labels. And it's just saying, are there features that are way more easily recognizable? Things like size, right? Like, what if, our extra small packages, there's and even if it's not like every single time, if 90 or 80 or more than 50% of the time an extra small package went to vessel number VA3, that like all these little small changes make an impact on your sort time. And in this industry, being able to have a better sort time means you might have a one up on your competitor. All right, so guys, I hope you guys are completely drawn in. This is an example of the data science projects that we're going to build in our data science bootcamp. This full project is based off of Xpert Logistics Solutions. This is a made-up company, and this is meant to prepare you guys if you were to go work for a real logistics company. Just walking you guys through some of the challenges that you might face in real life. And in a future video, we'll actually ingest some data. So for now, something that I didn't have the opportunity that would really help me in real life is when I was presented with a challenge, being able to go over the real life business use case, simulate that, and especially if I were able to visit, to like wrap your head around like in real life what is actually happening, it'll help you better understand the data. All right, I hope you guys enjoyed this freebie. If after watching this freebie, you guys are interested in joining our data science bootcamp, the information will be in the description. And if it's not, you guys can always go to www.lemonsqueeze-marketing.com for the latest news. All right, I will see you guys in the next tutorial. Peace.